This is Haseen from Assistant Professor from Municipal Department. Today, I'm going to tell the topic as mathematics in big data analytics. So first, what is mathematics? Mathematics is one of the concept of Hadoop. In Hadoop, there is a lot of revision process. I mean, it has a concepts of how the data should be transferred into a small data. Why? Because a Hadoop or a big data analytics must and should have the clusters of data. It should be reduce the data in a simplified manner to the storing of the data. So here first, the main concept of the Hadoop is mathematics. So what is mathematics? The mathematics is a data processing tool which is used to process the data parallelly in a distributed form. So it's one of the data processing tools in the Hadoop, and it should be used to process the data in parallelly distributed form. Is nothing but what are the equalized data should be parallelized in a sequence manner. Then it should be distributed those parallelized data in some of the specific equalized data. Then it was developed in 2004 on the basis of a paper titled as MapReduce Simplified Data Processing on Large Clusters, published by Google. So the MapReduce concept should be taken by the one of the most searched and most published paper from the Google as MapReduce. In this, the data should be simplified because it should be taken as a large amount of data, and that should be simplified by the data processing on a large cluster. Clusters is nothing but a huge amount of data, and that should be simplified. So using these concepts, the MapReduce concept should be developed by the in the Hadoop. So MapReduce is a software framework and programming model used for processing huge amounts of data. So here we already know that the large amount of data will have to be taken. In this MapReduce, it's one of the software framework. So we have a lot of frameworks with the different tools. So in Hadoop, MapReduce is one of the framework, and also it's a programming model also. So here, how the data should be reduced in these means, first, whatever data it should be taken, that should be in a text input format. After that, what are the input format it should be taken, the key value should be assigned on that data. After assigning the key values, it should be sequential data should be adopted on that key values. Then the sequence files should be, how much related data is there? Those all in a specific manner, the data should be accessed. After that, what are the data is specified, that should be simplified in a one or two data. For example, a repetitive data should be accidentally or coincidentally repeated in a text document. On that, what are the repeated data is there, and then how much the data should be repeated. That data, all repeated data should be converted in a single format, and it will give a key value pair on that. After that, whenever the, and also it should be given the addressing the data. After that, whenever data should be extracting the data, it should be gone into the reverse ordering. Is nothing but where the data should be taken, and then which address the data should be taken. So in a reverse order, what are the locations it should be stored? It should be taken from the address location, and which data should contain, the data should be delivered on that particular format. And next, what are the concepts in MapReduce are two phases. So namely as map and reduce. These two are the tasks should be performed in a MapReduce concept. So map tasks deal with splitting and mapping of data. So MapReduce, as well, we know that it should be two phases as a map and two reduce concepts. In map task, it's also have the two phases. One is splitting and another one is mapping. And reduce also have the two tasks. So those are shuffle and reduce. So map task should be taken the data, then splitting it. After that, mapping a specific key value pair. After that, it should be sent into the reduced task. In reduced task, data should be shuffled. So what are the related data is there? All the data should be shuffled on that way, and then store the data in a specific manner. After that, the related data should be shuffled on it. After, it should be sent it into the reduce. In reduce, the related all data should be taken in a single form and then reducing the huge amount of data in a single format. Then what are map tasks? So in this, we already know input splits and mapping. So what is input splits? An input to a map reduced in big data job is divided into pixel size pieces. So here, in a clusters of data, input splits, it should be taken the data. I mean, what are the, for example, we have a 5 GB of data. In splitting, it should be divided into 1 GB, 1 GB as separate. That is nothing but pixel size of pieces. So equal 5 GB data should be divided into 1 GB, 1 GB equally. That will make pixel size as 1 GB, right? After that, that is called as input splits. So input split is a chunk of the input that is consumed by a single map. So input splits is a chunk of input. Is nothing but data should be a single formatted data or a small piece of the data. Okay. After that, mapping. Mapping is the very first phase of the execution of the MapReduce program. In this phase, data in each split is passed through a mapping function to produce output values. What are the input we have to take in from the input splits? So, 5 GB data should be split into 1 GB equally in a specific pixel size, and that would be passed into the mapping. In each mapping, individual 1 GB data should be given a output values in the mapping. In our example, for example, consider a job of mapping phase to count number of occurrences of each word from input splits. How many input splits is there? It should be taken, and how much of in how many input splits is there? It should be given the some frequency to the those numbers. Is nothing but we already taken the example as 5 GB. On that, we have to split those 5 GB data into a 1 GB, 1 GB separately. On that 1 GB, so 1 GB as 1, 1 GB as 2, and 1 GB as 3, 1 GB as 4, 1 GB as 5. So 5 equalized data should be found on that. First 1 GB data is first data, and then 1 GB as a frequency of that data. And second one is second time of data, and that 1 GB as the a specific size of the second data. So meanwhile, third, fourth, fifth also same manner. Next, reduce task. So reduce task is nothing but reducing our data from taking the maps. So here it should also have taken the two phases as the shuffling and reducing. In this shuffling, you can see this phase consumes the output of mapping phase. This phase consumes the output of mapping phase. So it will be consumes the data. How much data should be taken from these mapping steps. Then its task is to consolidate the relevant records from mapping phase output. What are the outputs should came into the mapping? The data should be consolidated into these shuffling. In our example, the same words are clubbed together along with a respective frequency. In mapping, we have to given some frequency to the each individual data, right? On that individual data, what are the frequency you can give and that frequency, how much time it will be repeated, and what are the in individual repeated data, it should be taken in a one singular formatting. It's nothing but in mapping, 5 GB data we have to take in, and each and individual 1 GB data, what are the data is same in the all 1 GB data. On that all 1 GB data, similar data is taken into a one place. After that, these outputs should be sent into the reduce. In this phase, output values from the shuffling phase are aggregated. What are the output should came up into the shuffling phase? It should be aggregated. This phase combines values from shuffling phase and returns a single output value. For example, in shuffling, all five 1 GB data, there is a common word as and. Okay. On that and, it should be repeated as 5 equal times. In a 1 GB data, it should be repeatedly in first 1 GB and is there, and second 1 GB and is there, third 1 GB and is there, fourth 1 GB and is there, and the fifth 1 GB also have the and. And these 5 ands, it should be taken in a single output value. In shuffling and the mapping, we have the 5 and in a individual data. Whenever we come to the reducing, that and data is specified in only one time and with the frequency. In short, this phase summarizes the complete data set. And this is the complete data set of our map reduce. So next we have to see the one example further. Consider we have to follow the input data from your map reducing big data. Welcome to Hadoop. Class Hadoop is good, Hadoop is bad. This is the data. So what are the example data? Welcome to Hadoop. Class Hadoop is good, Hadoop is bad. This is the data. So how it should be works. First input. What I have to give in the input as welcome to Hadoop, class Hadoop is good, Hadoop is bad. This is the input I have to give in. Then it should be send it into the map tasks. So in that, what are the first step? Input splits. So here I have the data as welcome to Hadoop is one data, and then it should be splitted. What are the input I have to give, and it should be splitted in 4 sentences. Welcome to Hadoop is one sentence, and second one is Hadoop is, and class Hadoop is one sentence, and good Hadoop is one sentence, and bad is another one. So I have to given the 3 sentences and input split should be split our data in a 4 equalized data, and these equalized splits should have a fixed size. And after it will be sended these data into map. In that mapping, what are the input splits should be given? That should be giving in a data as well as assigning a one frequency for that individual data. How much frequency it have, that all to be given. In mapping, see here, welcome and welcome is 1. 1 is the frequency of that welcome, and 2 because of it should be repeated only one time, and 2 TO2 as 1. The frequency of 2 is 1. Hadoop. Hadoop is the 1. Next class Hadoop is. Class is 1. Hadoop is 1. Is 1 because individual data can repeated only one time. That's why I have to give in the 1 as the frequency. Even it should have to repeated also have to give in the frequency as 1. Why? Because here we have the repeated data now. The data should have to send it into the mapping. It will be given the frequency as 1. Whenever shuffling, the data should be taken the data as well as frequency as 1. In reducer, it should be take a different step for that. On that, the all data should be reduced. Okay. And next, good Hadoop is. Good is 1, Hadoop is 1, easy 1. And bad. Bad is the frequency as 1. After the completion of the mapping, individual data should be sent into the shuffling. What is shuffling? It's one of the main concept of the reduced task. In reduced task, what are the related data is there? All the data should be sent into at one place. So here, first, welcome with the frequency. So it should be gone into the class. Okay, according to the data as well as the frequency, it should be considered. Or you have to take them from the bad also. The bad 1. It should be shuffled in a bad and the frequency as 1. And next, class. Class is from the mapping. So it will be, for example, consider this is to be taken in the alphabetical order. Okay. So first, what are the order it should be taken? It's what are the first word is bad. And bad, they have the frequency as 1. After that, class. Class after then the frequency is 1. And there is no more bad or class is there in the mapping question. After that, Z for good. So good here is there in the third set. In third set, good I have taken and then shuffling that into a good with a frequency. Next, Hadoop. Hadoop is repeated 3 times. See here, in the first set, Hadoop with the frequency as 1 I have to taken. And next, second set, Hadoop is there and taken into the here in shuffling. And Hadoop is there in the third set that also to be taken into Hadoop with the frequency. You understand? After that is. In first set, there is no is. Second set, is there. And I have to take this is as 1 with the frequency. And third set also is there with the frequency as 1. Next, 2. And last, welcome. So here you observe that in each step, how many times the repeated data is there, that all to be set into a one single place. So So bad only comes at one time in the entire inputs data. And class also come into only one time at the entire input data. And good also come into one time at the input data. Hadoop, see here, the Hadoop is repeated by 3 times and is also repeated by 2 times. Next, 2 is one time and welcome is 1. Okay. And after shuffling, the data should be sent into reducer. In reducer, bad is 2. So bad should be taken into one time because it should be repeated only one time. And class also one time, so it should be taken as one time. And good also one time, and here also taken a one time. See here, Hadoop is repeated by 3 times. Okay, and here in reducer format, the data Hadoop is taken into only one time, and how many times it should be repeated. The count of frequency should be taken. So how much of count is there? 1, 2, 3. So 3 times it should be repeated. So whatever the data is repeated, the data should be taken only one time, and the frequency is to be taken into 3. As 3 times it should be repeated. And is also. Is taken into one time. And how many times it should be repeated? 2 times. The 2 should be taken into frequency. And 2 is one time and welcome also one time. For the final output, so whatever the data is taken from the reducer. So bad 1, class 1, good 1, Hadoop 3, is 2, 2, 1, welcome 1. This is the final output of the data. So here, see the input, welcome to Hadoop, good class Hadoop is, good Hadoop is form. How many times it should be repeated to Hadoop and is? So it should be reduced in this form. So we have to taken only a small amount of data. In big data, we have a huge amount of data should be repeated. On that repeated data has to be taken in a many more times. On that, how many times the data is repeated, it should be added into the frequency. I mean, data should be first splits, then mapping. After mapping, the shuffling. Mapping and shuffling is the very key role on. After the red is also a key role. These four are the key roles of the entire map reduce concept. Whenever the reduce five GBs of data should be divided into a 3 GBs of data. And see the one more example. This is an apple. Apple is in red. No, sorry, apple is red in color. So this is the input data. Input states it should be taken into 2 times. This is an apple. Apple is in red color. So mapping, this is 1 with the frequency. Is 1. An is 1. Apple is 1 with the frequencies. And apple is 1. Is 1. Red is 1. In is 1. And color is 1. And next it will be sent it into the shuffling. This is one is in first set is there one time and the second set is there, so it should be taken into one time in a specific spacing. And next an is one time, there is no an in second set. Apple is one time, and here also the apple is one, and then here is already there, apple is also there, and then red is one, in is one, and color is one. And here reducing concept. In reducing, this is one, is repeated two times. That's why data should be taken a single time. And the how many times it should be repeated? The repeated data is taken. How many times? Two times. Or the in reducing, is repeated by two as a frequency. And adding one time, apple here also apple have the two times repeated, and the frequency as two. That is one, in is one, color is one. So this is an apple. So here is an apple as repeated two times. That's why it should be taken the frequency as two, and remaining all are one time. So this is the red news. So here we have to take in only the one little bit of amount of data. Whenever we have to go for the big data, there is a lot of data should be specified. On that huge amount of data clusters of data should be divided into splits. Then it have to mapping, then shuffling and reducing. So after reducing these clusters of data, it should be minimizing the data. It should be more useful to storage of the data. The storage space is somewhat reducing into our systems. Thank you.